Hello and welcome back to Math with Mrs. Becker. Today we are looking at Algebra 2, Chapter 2, Section 5. We will be graphing linear inequalities. Remember, an inequality means you will have symbols such as greater than, less than, greater than or equal to, less than or equal to. Because our inequalities are going to contain two variables, we will get diagonal lines, okay? It says a linear inequality in two variables relates two different variables or quantities using an inequality symbol, okay? Something like this. So it's very similar to what we have been working with when we had y equals mx plus b. The main change here is that we're changing the equals to an inequality. Now, when you graph this, you need to create what is called a boundary line. A boundary line divides the whole coordinate plane into two regions. So the main thing is just to make sure that when you connect those points to form a line, that you go all the way through the plane so you can say, okay, I have this piece and this piece. So it divides the coordinate plane into two different regions. Now remember, when you graph inequalities on a number line, there are times where you have open circles and there are times when you have filled in circles. Same thing when you're graphing lines on the coordinate plane if it's an inequality. If you have these symbols, less than or equal to or greater than or equal to, these would be solid or filled in lines, because if you had a circle, it would be a filled in circle. So if you would have put in a filled in circle, you will have a filled in line. Now here, if you have a less than or a greater than symbol, you are going to have dotted lines. So the way I think of it, as if I was graphing this on a number line, okay, this would be an open circle. So your lines have to have openings as well. So it matches. Before you connect the points, just ask yourself, would it be a filled in circle or an open circle? If you would have had a filled in circle, it's a filled in solid line. If you would have had an open circle, it's a dotted line that has openings. Then what you get to do is shade. So your dotted line or your solid line, that is called a boundary, and it takes your coordinate plane and it separates it into two regions. One of those regions is true. One of those regions is false. The true region means you could pick any ordered pair from that region and fill it into that inequality, and you would get a true statement. It is so cool, okay? And what you have to do is figure out which side is true, then you shade it. So the shaded region is the true region. And I do think a lot of this will make more sense once we start trying. So let's go for it. Think of this as y equals negative 1/3 x plus 2. And the only reason why I'm doing that is because we are pretty darn comfortable graphing things in this format. This is slope-intercept form. Whatever's after the x, that's your starting point. Because it's a plus 2, I go up 2. Now the value in front of x, that's your slope. It's negative, so I go down the top number. So it's down 1, go to the right, 1, 2, 3. There's your 2 points. Now what I need to do is connect them and make a boundary line. So I'm going to go ahead, before I make the line, on a number line, this symbol represents an open circle. So my line also has to have openings. And this is what I mean by a boundary line. It has to go all the way through. You can't just connect these 2 points. It has to go from one side of the graph to the other. Now we get to have some fun. We have to figure out which side is true and which side is false. So what you do, you pick any point not on the line. 9 times out of 10, you'll be able to pick 0, 0. The reason why 0, 0 is so helpful is because it's really, really easy to calculate, okay? If I test 0, 0, remember your ordered pair, the first value is the x, the second value is the y. So I go ahead and I replace the x and y in the inequality. Y is being replaced with a 0, greater than, negative 1/3 times 0 is 0, 0 plus 2 is 2. So at this point, I have a statement. I have to figure out, is it true or false? This says 0 is greater than 2. That is false. What that means is that the side that contains the point we tried, that's the false side. You shade the true side. So if the side that has 0, 0 is false, This side of the line is true, so you shade it and we're done. And what this ultimately means is any ordered pair that is within the shaded region, you could take that point, fill it into the original, and when you got down to here where you had a statement, all of these would result in true. Okay, I hope that made sense, but if not, don't worry, we have a lot more to look at. Okay, oh, remember if you only have X or you only have Y, you no longer have a diagonal line. This is when you get a vertical or you get a horizontal line. If Y is by itself, we need a line that cuts through the Y-axis. The Y-axis runs up and down. In order to cut an up and down line, you need to run side to side. So I need to cut at -1. This would be a solid line. Boundary line means I have to go all the way through the coordinate plane. So I graphed it. Now we need to figure out, okay, is this true or is this true? So you pick any ordered pair. I'm going to go ahead and pick 0, 0 again. When you pick 0, 0, yes, it has an X and a Y. There are no X's in this equation, but that's totally okay. You just replace what you have. We have a Y, and in this ordered pair, the Y value is 0. So my statement reads 0 is less than or equal to -1. I know a lot of times people struggle with negatives. If you are one of those individuals, think of this as temperature. This statement is saying that 0 is colder, it's less than -1. Well, that's false. So that means that the side that has this point, that's the false side. So the other side of the line, that, my friends, is the true side. Those of you who like to color, this is your day. Okay, let's do another one. Again, this is in the format y equals mx plus b. So whatever is after x, that's your starting point. So I go down 2. There's my point. 3 is your slope. Remember, you can take any number and turn it into a fraction by putting a 1 underneath. This is positive, so I go up 1, 2, 3, go to the right 1. There's my 2 points. Before you connect them to make your boundary line, you have to check. If I was graphing on a number line, this would be a filled-in circle, so this is a filled-in line. Make sure it goes all the way, so now you have 2 sides, this side and this side. And just to show you that you can use other values besides 0, 0, let's pick this point. If I pick 4 and 0, you just have to pick any point that's not on the line, okay? The x here is a 4, the y is a 0. You fill those values in to see if this point is in the true side or the false side. So y is 0. Is 0 greater than or equal to? This is a 4. 3 times 4 is 12. 12 minus 2 is 10. Is 0 greater than or equal to 10? No, so it's false. That means that this side, the side that contains the point we tried, that's the false side. So this side must be the true side. Hope you're having fun. All right, let's keep going. Okay, so this time I just have an x, okay? So it's just an x. In order to cut an x-axis, because that runs side to side, I need a line that goes up or down, okay? X runs side to side, so this is negative, so I have to travel to the left. I need a line that cuts right through there. This would be a dotted line, because on a number line, it would be a filled-in circle. So I have a dotted line because it has to have openings. Now we have to test a point. Let's go ahead and let's just test this point, okay? It's not on the line. -4 and 0. So any x's I can replace with -4, any y's I can replace with 0. It's okay that my inequality does not have a y. It has an x, so I replace it. Is -4 less than -3? So again, those of you who want to think of temperature, is -4 colder than -3? Ding, ding, ding! It sure is, so that's true. That means that the side that has the point that I tested, that's the true side. So you shade the side that contains that point. Okay, now here's just a little reminder. If you ever have an equation where x and y are on the same side, remember that's called standard form, and one of the easiest ways that you can graph something in standard form is to find the intercepts. Okay, so same process, even though we have a less than or equal to symbol, the work is the same. To find the intercepts, 1 point you're going to have a 0 for x, 1 point, you're going to have a 0 for y. So if I put in a 0 for x, 3 times 0 would be 0, so that would cancel. What I would have remaining is 4y equals 12. To get y by itself, let's divide by 4. 12 divided by 4 is 3. Now to get y by itself, to put a 0 in for y, if I put in that 0, 4 times 0 is 0. I need to get x by itself. What I'd have remaining is 3x equals 12. To get x by itself, you divide by 3. 12 divided by 3 is 4. It only takes 2 points to make a line. So here are your 2 points. Stay at 0, go up 3, there's 1. Go to the right 4, stay at 0. Now, before you make your boundary line, should this be solid or dotted? Well, this is going to be a solid line. Boundary all the way through. I have 2 sides. One of these sides is true, one of these sides is false. Let's do a test point. I'm going to go back to 0, 0 because I really like working with 0, 0. I just wanted to make sure I did a few so you realized you can test anything that's not on the line. Okay, so I'm changing x and y to 0. Check this out. If this becomes a 0 and this becomes a 0, this would end up being 0 plus 0. That's 0. Is 0 less than or equal to 12? Well, absolutely 0 is less than 12. So the side that contains 0, 0, that's the true side. So you shade the side that has 0, 0 in it. And what that means is you could pick any point here, any ordered pair. I could pick negative 2, 0. I could pick 0, 2. I could pick negative 2, 2. Anything that's in this region, and if you filled it into the original, you would end up with a true statement. So much fun. Okay, one more, and then we get to talk about carnivals. Okay, so if you have x's and y's on the same side of the inequality, the easiest way to graph is to go ahead and do the intercepts. To find the intercepts, one ordered pair will have a 0 for x, the other ordered pair will have a 0 for y. If I put in a 0 for x, 3 times 0 is 0, this is what I have. To solve for y, I need to divide by negative 4. 12 divided by negative 4 is negative 3. Now if I put in a 0 for y, negative 4 times 0 is 0. So what I have remaining is 3x equals 12. Divide the 3, 12 divided by 3 is 4. So I have a point at 0, down 3. This is go to the right 4, don't go up or down. Now you make your boundary line. This would be an open circle on a number line. So when I make my line, I need to go ahead and make sure that I have openings, meaning it's a dotted line. Okay, now you do a test point. You pick any point not on the line. 0, 0 is available. So I'm going to turn my x into a 0 and my y into a 0. Well, if that's a 0 and that's a 0, I end up with the statement 0 is greater than 12. Well, is 0 greater than 12? Heck no. It's like money. Would you rather have $0 or $12? Okay, you definitely would want the 12 because this is less. So this 0, 0 is in the false side, so you don't shade that. You always shade the true side. If 0, 0 is in the false side, that means on the other side of the line, that's where you have your true points. Let's keep on going. A school carnival charges $4.50 for adults and $3 for children. The school needs to make at least $135 to cover expenses. Use X as the number of adult tickets, Y as the number of child tickets. Write an inequality for the amount that the school makes on ticket sales. Well, it's $4.50 per adult. Adult is X. Plus they make money on child tickets. $3 per child. Y is the number of child tickets. Now the school needs to make at least $135. This is how much money they make. They need this to be greater than or equal to 135. So they need to make at least this. That means it's okay to be equal to 135. At least they're making their money back. But it's probably better if they make more because then it can be kind of like a fundraiser. So there is your inequality. Turn the page. Okay, so I have my inequality. $4.50 X plus $3 Y, we need to make at least $135. Okay, so that's where I'm at. Graph the inequality by finding the intercepts. So this means if I have a 0 in for X, this is the adults. This means no adults show up to the carnival. No adults are there. They drop their kids off at the door and they're like, hey, go have fun, see you later. To solve for y, how many kids would you need? Take 135 divided by 3. 135 divided by 3, you would need 45 kids to show up. That's a scary thought considering that the adults just dropped them off. Let's say you have like a parent date night and there are no students there. They're like, hey, no kids, let's do adult night at the carnival. You would have to divide the 450 over. If I take $135 divided by $4.50, you would need 30 adults. So here are my 2 points. Stay at 0, go up 45. Go to the right 30. Now this is your boundary line. Before you sketch it, if you look at our inequality, this would be a solid line. Now we need to figure out, okay, do we need these combinations of adults and children or these combinations? Okay, so we have to go ahead and shade. I'm going to put 0, 0 in there because 0, 0, I can do that as a test point. Okay, I'm going to go ahead and do a different color just so we can follow what's going on. If I put in a 0 for X and a 0 for Y, nobody shows up at the carnival. No children, no adults. What they're making is a big 0. Is 0 greater than or equal to 35? No, if nobody shows up, they're not making enough money. So that means the side with 0, 0 is the false side. So this side is the true side. So at the carnival, for them to make the amount of money that they need any of these combinations. So 40 adults and 10 children, that works. 50 adults and 30 children, that works. Any combination in here will get them enough money. Now here's a question. If 25 child tickets are sold, how many adult tickets must you sell? So they're taking this and having us use it. Y represents child tickets. So if they said 25 child tickets were used, Y is really a 25. So I have $4.50 per adult plus $3 per child. They just told us 25 children came to the carnival. What I need to do is solve for X. If I take $3 times 25, I would have $75. We need to make 135. To solve for X, I would minus 75. So $4.50 X is greater than or equal to 135 divided by 75. Sorry, minus. I'm minusing 75. 135 minus 75 is 60. Now I divide by $4.50. X, 60 divided by $4.50. X would have to be, okay, so we get an odd number here. Okay, so if I have 135 minus 75, I'm just double checking, divide by $4.50, yep, I get 13.3. Well, you can't have like 0.3 of an adult showing up. So what has to happen is you need to round up. So you would need your amount of adults to be greater than or equal to 14. Okay, so what we had to do there was go ahead and fill in a value and solve. Okay, so I went ahead and did that. I just think it's funny that I gave you a problem where we needed 13.3 adults. My bad. Round up to the nearest whole adult. We don't need 13 adults and an arm, but this is the correct number. All right, let's go ahead and do one more story problem. Hopefully this one's not as crazy. A cafe gives away prizes. A large prize costs the cafe $125. The small prize costs them $40. The cafe cannot spend more than $1,500. So that's how much money they have. They can spend $1,500 for prizes, and obviously they can spend less, but they can't go over that because they don't have enough money to do that. How much of each prize can be awarded? Let X represent small prizes. Let Y represent large prizes. You cannot exceed, meaning you cannot go over $1,500. Okay, so X is a small prize. A small prize costs 40, so 40X. Plus, they're buying large prizes. Large prizes cost $125. Y represents the large prizes. This is how much they're spending. This has to be less than or equal to $1,500. You cannot go over $1,500. That's how much money they have. Turn the page. Okay, so I go ahead and I have 40X plus 125Y is less than or equal to 1,500. Let's go ahead and graph this. We want to graph finding the intercepts. So what this means, 0 for x means, hey, we're not doing any small prizes. Let's just bring out the big prizes. So if I put in a 0, that will cancel. To find out y, how many big prizes, divide by 125. So 1,500 divided by 125, you could get 12 big prizes. Well, what if they're thinking, okay, maybe it's better to have more small prizes, so they're not going to get any big prizes. They put in a 0 there. So I'd have 40x equals 1,500. To solve for x, divide by 40. 1,500 divided by 40, they could get 37.5 prizes. Okay, so those are your points that are going to form the line. So 0, 12, 37.5, and 0. This would be a filled in circle on a number line. So it's a filled in line. Now we need to figure out, okay, which side do I shape? So you pick any point that is not on the line. I'm going to put in 0, 0. So if I plug in 0, 0, that means the x becomes a 0 and the y becomes a 0. So what happens here is they're like, we don't need prizes. Let's just not buy any prizes at all. So if they don't buy any prizes, how much do they spend? 0. 0 is less than or equal to 1,500. Well, is 0 less than 1,500? True. So the side that has 0, 0, that is my true side. So that means any of these combinations are what the cafe can buy and make sure that they stay within their price range. Here's a question. Now they want us to go ahead and use this. How many small prizes can be awarded if they order 4 large? So y is large, y is 4. So 40 times x plus 125 times 4 is less than or equal to 1,500. If I go ahead and I take 125 times 4, I get 500. So 40x plus 500 is less than or equal to 1,500. I am solving for x. To get rid of a plus 500, I need to minus 500. So I would have 40x is less than or equal to, make sure that you are maintaining that symbol, 1,000, because 1,500 minus 500. Now to solve for x, you need to divide everything by 40. 1,000 divided by 40 is 25. So x, if they buy 4 large prizes, you could buy up to 25 small prizes. Couple more examples for the day. Okay, now one thing, you can, if you are solving this type of thing, they're going to give you multiple or multi-step inequalities as well. So what I want to do is go ahead and I'm going to distribute, okay? The other thing you could do is divide 3/4. And remember, you cannot divide fractions. So you'd have to do flip, skip, multiply, that whole bit. You'd have to keep the 6 the same, change divide to multiply, do the reciprocal, making it 4/3. Both options are okay. All right, so if I go ahead and I'm multiplying, remember when you multiply fractions, it's top times top, bottom times bottom. So 3 times 8 is 24. 4 times 1 is 4, that's connected to an x. Minus, now 2, as a fraction, it's 2 over 1. Top times top. 3 times 2 is 6. Over 4 times 1 is 4, that's connected to a y, that's greater than 6. Now I can simplify this. 24 over 4, well, that's 6x, minus 6 over 4. I can divide both top and bottom by 2, leaving me 3/2 y is greater than 6. If I want to go ahead and graph this, x and y are on the same side, so go ahead and find those intercepts. If I put in a 0 for x, this is what I would have. Negative 3/2 y is greater than 6. So what you're actually doing here is dividing by negative 3/2. You cannot divide fractions. Okay, and one thing to think of here as well, if we were writing out the solution, remember anytime you divide by a negative, you'd have to flip the sign. Okay, but I can't divide by a fraction, so you keep the 6 the same. Change divide to multiply. You have to do the reciprocal of whatever you're dividing by. So this would be negative 2 over 3. Now I can go top times top, negative 12, bottom times bottom, 3. So y would be less than negative 4. So if I put a 0 in for x, My y value is a negative 4. Now this one's going to be a little bit easier. If I put in a 0 for y, I cancel that whole fraction. What I have is 6x equals 6. If you divide by 6, 6 divided by 6, that's a nice 1. I did put this because from homework, I know some of you struggle with the whole fraction thing. So I just want to make sure that you are working with things like you cannot divide fractions. You have to go ahead, change it to multiply and do the reciprocal. When you're multiplying fractions, you have to remember it's top times top, bottom times bottom. You only need a common denominator if you're adding or subtracting. So some of those little fraction skills that make things a little bit tougher, I'm hoping that we can overcome those by practicing some of these types of problems. So here are my two ordered pairs. When I put in a 0 for x, I ended up with negative 4. When I put in a 0 for y, I ended up with a 1. Now when I go to make my boundary line, this would be an open circle. So my line has openings. Now what I have to do is do a test point. So I'm going to go ahead and do 0, 0. Okay, if I put in 0, 0, I'm going to go to here where I went ahead and got rid of my parentheses. If this is a 0 and this is a 0, this whole side would be 0. My statement would be 0 is greater than 6. Well, is 0 greater than 6? No way, Jose. That's false. 0 is not greater than 6, so the side that has 0, 0 is the false side. That means that the other side is the true side. Last question. Tomorrow is a work day on this assignment. Today was just to go ahead and just practice and watch the video and make sure that you understand what's going on. Okay, the other way that you could do this, the last one, we went ahead and distributed. Remember, we talked about this when it was an equal sign. If you have a number that you are distributing, rather than distributing it in, if this side is one number, you can go ahead and divide it over right away, okay? This would be 3x minus 4y. The symbol is greater than 24 divided by 2 is 12. So you could distribute or you can divide it over. Either option is great. At that point, you just have two different options. If I want to graph, because x and y are on the same side, if I put in a 0 for x, the x term will cancel. What I'd have to do is take 12 divided by negative 4, you get a negative 3. If I put in a 0 for y, the y term cancels. To get x by itself, I'd have to take 12 divided by 3, that's a 4. So 0, down 3, 4, stay at 0. This would be a dotted line. Make sure it's a boundary, meaning that it goes all the way through. Pick any point not on the line. I am testing 0, 0. If I put in a 0 here and a 0 here, that side, everything would become a 0. The statement would say 0 is greater than 12. Well, 0 is not greater than 12. That is a false statement, so that means the side that contains 0, 0 is false, which means that the other side of the line is the true statement. So this was your assignment today. All you had to do was watch the video, learn some fun new ideas, make sure you complete the notes. Tomorrow is a work day. Okay, so you're doing 1 to 27 and 41. You can find those on pages 128 through 130. And when you are done, go ahead and take a picture of your completed assignment, upload it to Google Classroom. I hope you had fun today and enjoy your workday tomorrow. Talk to you soon.